Okay, so today's goal, today's job, calculate the instantaneous velocity of a displacement time or position time graph. Now I've neglected to do the little notes on instantaneous time and time interval, but I think I can do it without even making you write any notes down. So when I say time instant, what kind of comes to mind? Instant of time. 1 point. Should it be a second long? It could be like in fact, it's, what would you say the length of time of an instant is? Infinitely small. There is no length to it, right? It's just a single point in time, exactly. Whereas an interval is two of those points and sort of the difference between them, right? There's an initial and there's a final time, right? Okay, so I think everyone sort of gets that. It's pretty straightforward. So when I say instantaneous velocity, what does that kind of mean? At that point, at that instant time, how fast you're going at that time, right? If you get stopped for speeding, it's not your average velocity that matters, it's your how fast you're going when the police see you, right? When they see you. So average would have to be over a period of time, right? Okay. All right. So far, just as a bit of by way of review here, we've determined displacement from a DT graph, and how do we do that? Reading 2 points off the graph and subtract. So we just sort of do this kind of thing, and you're going to have a chance to review this right away. Remember doing that? 2 points, subtract, right? And we have determined average velocity from a DT graph by dividing that displacement by the time interval. And when we find average velocity, we're really finding the what of the line? The slope. We're really finding the slope of the line. Slope is average velocity. So you might be thinking ahead a little bit. Actually, I don't want you to, because first we're going to, yes, review. I've forgotten what's coming up. So let's do this part first before I ask you that question. So by way of review, let's find displacement and average velocity for those 6 intervals. Now in the morning class, they wanted me to do a couple to help them. Should I do that? Yeah? No? We're good? I see a few yes. If you don't want, you put your head down, you go to work. If you do want, keep your head up and watch. Okay, so find displacement and average velocity for interval A from 0 to 2 seconds. So we are talking about this period of time right there, right? 0 to 2 seconds? Excellent. Okay, and we're finding the slope. So the displacement is simply the point. So that is 6. That data point is 0. So it's going to be 6 minus 0. My displacement then is 6. And what is my time interval? 2 minus 0. My time interval is 2. 6 divided by 2 is 3 meters per second. That is the average velocity. Give me the nod of understanding. But only if you mean it. Okay. I ask you this. What is the velocity, say, at exactly 1 second? How fast is it going right there? At that little black little dot. Is it not going 3 meters per second? What does the straight line mean? Constant speed. What does constant mean? It means it doesn't change, right? So if the average is 3, that means that every single dot, it's going 3. It's like getting 95% on every test. What's your average? 95. You get constantly 95. Okay, what's B going to be? What's the average velocity going to be? You can do it without even calculating. How do you know it's 0? Because the line is flat. It is stopped. Flat. What about C from 6 to 10? Well, that's this interval here. So that's going to be minus 10, subtract 6, giving us a displacement of minus 16. Right? You can count if you want, minus 16. And the time is 10 minus 6, which is 4. So my average velocity is minus 4. And what does the minus 4 mean? The minus part? Going to the left, exactly. At a constant rate, -4. Every single point on that line, what's the slope at every point? -4. Okay, you guys go do D, E, and F. No grief with F. I usually expect some grief. That was pretty easy. Okay, well, that's good. Let's just check them here. D, well, D is easy because it's 0, because it's flat. E is only 1 second long, so it's the slope here. So I end up at -4. Subtract, this is -10. So, oh, hang on here. Subtract -10, right? Minus, that's +10. It should be 6, right? And the time there is over 1 second, 13 minus 12, so 6 over 1, or 6 meters per second. But what do you do when it's a curvy line like this? We haven't seen a curvy line yet, have we? We have not. But we are interested in the average. And so all you do is find the slope of the line that connects the two endpoints. Okay? That's all you need to do. So in fact, this is going to be 0 minus -4, which is 4. 0 minus -4. And the slope of the x is 18 minus 13. Right? 18 minus 13, which is 5. 4 over 5. The average is 0.8 meters per second. Does that make sense? How do you find the average velocity? Find the slope. And it doesn't matter whether it's straight or whether it's curved. Doesn't matter. Okay, now I know from the morning that you guys got to do some filling in the blanks over here, right, or something? Maybe some of you started already? Let's just double check here. So it says, at the bottom there, in the graph, the slope of the line in time interval A would yield the average velocity. There it is right there. The average velocity for that timer. The slope would yield the average velocity for that time interval. In general, average velocity is, this is still on page 1, average velocity is the slope of the line joining the endpoints of the time interval. Average velocity is the slope of the line joining the endpoints of the time interval. This is true for straight lines and curved lines like interval x. I'll just pause there for a second. Is it? That's not what today's class is about. Today's class is about finding instantaneous velocity. How fast it's going at a single point. Now, in the morning class, someone says, man, don't you need 2 points to find slope? The answer to that is? Yeah. So how do you find slope at a single point? Well, that's what we're going to find out right away. Okay. So, and I know you don't have that graph on the next page. It's the same one on the front, right? Instantaneous velocity is, you do have to flip your page over. Instantaneous velocity is the slope of a line at a single point, or a time instant. The slope of a line at a single point. Now again, I realize you don't have that graph, but you don't really need it. Slope of a line at a single point. So I've sort of alluded to this already. I've sort of been dropping some hints here. Like if you need to find, whoops, I wanted it to be colored. If you need to find the slope of the line at that single point, well, how do you do it? Just find the slope of the line, because the slope at every point is the same. Do you have to pick the endpoints? No, you can pick any 2 points you want. A lot of times they do it. It's a bad habit to get into, and really, in math class, they take the 2 endpoints. Okay, and kids think they always have to do the endpoints, but they don't. Okay, so you simply take any 2 points and find the slope. So I think I've got that over here. Easy for straight line segments. Easy for straight line segments. V inst is simply the slope of the line. V inst is simply the slope of the line, since the slope remains constant. And that's the first thing you got to write down at the top of page 2. So instantaneous velocity, when the line is straight, just find the slope. Again, it boils down to find the slope. The only real stumbling block comes when it is a curved line. Pause for. Okay, so what about you? This is all just review here. You've already seen this. For curved line segment F, how do you do it? You find the slope of the tangent line. The slope of the tangent line. Now your face kind of looks like this guy, which is the emoticon, I believe. No, it's not? You've never seen that before? I write that for, I don't know how you make it. I don't know. Get your phone out and try it. It would be like. You can't put question marks. No, but I bet you if you go. No, I bet you if you go like right parentheses question mark, what does it give you? Right parentheses question mark. What? No? What kind of cheap phone you guys got? Yeah, why make a smiley face like that? It doesn't turn it, no? I'm gonna start that. I'm gonna make a new trend. It's gonna go viral. Okay. So, anyways, the slope of the line is the slope of the tangent line. Now, do you guys know what a tangent line is? Have you ever heard that before? Tangent line. Maybe some of you. What does it mean? Okay, so put your pens down and just watch. Do not write. Ms. Mathe, if you see someone writing, go over there and take their pen away. Do not write. Just watch. Tangent line only touches the curve at one point. Rashton, you're writing, not listening. Only touches the curve at one point and estimates the curve at that single point. I'm going to do this. Okay? So see this green line right here? It just touches the blue line at a single point. Like if you zoomed way in, it would be close but not touching, right? It's just touching, just kind of coming up and kissing it right there, right? And it estimates the curve at that single point. It's an approximation, an estimate of the curve at that point. You can also think of it this way. If you zoomed way in like a microscope, zoom way in on that curvy blue line, eventually you got so far zoomed in that the curvy line would appear straight. And then if you took that little straight segment and you did what? Stretched it out, and then zoomed way out, you would see the green tangent line. Okay, so the green tangent line is the slope of the blue line at that single point. We still don't know how to find the slope. How do I find the slope of the green line? Well, it's a straight line. So what do? Take any 2 points. They do not have to be the endpoints. They do not have to be on either side of the black dot. Any 2 points and find the slope. Okay, go ahead and write. I say any 2 points on the line. So I say again, because I know you're going to ask me, how do I do this? What do? You draw a tangent line. Now, how do you know how to do it? You literally take your ruler, and it's really hard for me to show this because I can't put a ruler over there and you can see it. But you literally take a ruler and do what? You do that. Your line has to just touch the curvy line at a single point and has to be a good approximation of the slope of the line. Are you going to get a different one from the person beside you? Possibly. Is that okay? Uh-huh. Even if you get the same line, can you pick different points? Uh-huh. As long as you get an answer that is reasonably close and you've shown your work, you'll be fine. Okay? Good job. Okay, so I think the next thing to do is practice, right? Am I right? I have a few. Oh, hang on, one more thing. Yeah, you can just use a straight edge too. I'll get your ruler. When the DT graph is curved like this, it is called variable motion. Variable motion because the velocity varies. It changes. You can usually use calculator as will work too. Even the edge of your phone will work. It can. It should only, like, on one like this, Danielle's asking if it can go through it. One like this, the answer is no, because it's curving away, right? Like this one here, you can't put it through that. That's not a tangent. Alright, it's not to it, but you're talking about the next one, I think. Yeah. So as long as it's sort of like, you know, part of the curve where it doesn't matter, then yeah. Like, could it go through it up here? Is that what you're saying, Danielle? Like, could it be like, kind of like that? Well, that's kind of no good, right? But can it touch up here? Yeah. That has nothing to do with this point. Okay, I'll give you a couple minutes to try that. I'm going to take my ruler here and I'm going to put it on there. And I'm going to draw that line, okay? And is it okay if it goes through up here? Yeah, that's okay, because like this is like part of the graph that doesn't matter, right? Pick 2 points. Now here I don't really have any points, although, you know what, it does go through that point there, doesn't it? Right, so I'm going to pick this point as 10, 30. And let's pick another one. Any 2 points. I'd say it's a little bit below 0 and 10, but sure, why not? Let's go right there. So we'll say 0. Should we say 10? No. I'm going to say 9.7. Okay. Again, if you show your work, you mark the points and do the slope, the number doesn't matter a whole lot. As long, like if I got 4.3 and you got 47, that's wrong. Right? I can tell right away. But if you're close to 4.3 in the right ballpark, you'll be fine. So we're going to go 30 minus 9.7, which is 20.3. And this is going to be my x is going to be 10 minus 0, which is 10. And so I get 20.3 divided by 10, or 2.03 meters per second. Okay? Absolutely. That's in the right ballpark. Anywhere from about 1 to about 3 is good enough. No? Connor's my conscience. He tells me when I'm not recording. I know you can't see the ruler. Oh, I did it again. Come on. There we go. Okay, you got to match the curvature of the line, right? Does it matter that it crosses down here? No, because, I mean, the curvature's changed, right? I don't care about down there. Kayla, you watching? Pick 2 points, any points. I'm going to go with 8 right here. So I'm going to pick that point there. And let's go with 4. We'll just estimate. Right, so mark those off. So 8 and it looks like about, geez, it's almost 20. I'm going to say that's 8, 20, and I'm going to say this one is 4, I'm going to say 14. Okay, so my slope is the y's, y2 minus y1, 20 minus 14, all over 8 minus 4, 6 over 4, which is 1.5 meters per second. Now, do you guys know what the symbol for approximately equals is? Yeah. What is it? It's like the curvy equals, right? So you might see that in some of my handwritten solutions. You might see something like this. Approximately 1.5. Which means anything in that ballpark is fair. It really depends on the numbers on the side. I can't give you a hard and fast. You guys are worried about that. Don't be worried about it. Draw the line, make sure it's close to the slope, pick 2 points and do the right? And you'll be fine. That's close, Brady. Yeah. I don't need to know everyone's number. We'll be here all day if I hear everyone's number. That was one person. And we've already spent 20 seconds on this conversation.
I didn't say at the same time.
Okay. Practice 3. You've got a bunch of points, right? So it's going to be like this and like that. Okay, so go ahead and try that one. If you are done, you want to go on, there are 4 practice graphs there at the back.